everyone. Today I will discuss single phase semi converter drives. So in this single phase semi converter drive, first we will take the source here V, or we will consider as E, and it is connected to two thyristors as well as two diodes. Semi means we will consider as two thyristors and two diodes. If we will consider total 4 thyristors, it will considered as full converter. So we are considering only 2 thyristors, so we are calling it as semi converter drives. For this semi converter, it is connected through a freewheeling diode in parallel with armature resistance Ra and inductance La, which is connected to a motor, and motor consists of back EMF. No, it is represented with Eb. Here this is back EMF, armature resistance, armature inductance, as well as it is separately excited. No, so the field will be excited separately here. So this is the field winding, a field current is passing through it, and semi converter drive we will call it as single quadrant converter. Single quadrant converter. We will call single quadrant converter because the voltage and current, if you observe here, it is in first quadrant. The voltage and current are both are positive here, positive, and they are in the only one quadrant. So we will call it as semi converter drives as single quadrant converters. Next we will move on to waveforms. If the separately excited motor is connected to a single phase semi converter drive, the waveforms will be. So this is the waveforms. For this waveform, if we observe the source voltage will be alternatively every 180 degrees it will changes its polarity. From 0 to pi it is having a positive half cycle, and pi to 2 pi it is having a negative half cycle. So same will be repeated here, pi, 2 pi, and 3 pi and 4 pi. So this is the source voltage, and the supply voltage here it is there, no. So it will follows like this waveform. This is the supply voltage waveform, and VAB and VBA will be changes, and this is a gate pulse. Second waveform is a gate pulse. For thyristor there are two conditions, no. For thyristor to turn on the thyristor, two conditions. First condition, it should be forward biased. And second condition is gate pulse should be applied. So to turn on a thyristor, two conditions are required. It should be forward biased and gate pulse is required. So here if you observe at alpha, at pi plus alpha, 2 pi plus alpha and 3 pi plus alpha, the gate pulses are applied. So we will move on to first waveform V0. So we will write here for alpha to pi. If you observe from alpha to pi, so from alpha to pi, the thyristor T1 and D2, if you see in this, if you observe here, the thyristor T1 will be forward biased at an angle alpha. So thyristor T1 will be forward biased, and diode D2 will be forward biased. So here T1 and D2 will be forward biased from alpha to pi. So we will see the waveforms. See here, from alpha to pi, the thyristor T1 and D2 will be forward biased. So if you observe here, the voltage waveform will follows the source voltage waveform. If you observe here, this is the source voltage, no. So same this source voltage will follows here T1 and D2. So the waveform V0 will have same waveform as source voltage. Waveform similar to source voltage. Waveform will be similar to source voltage, and for this cycle the current I0 will also have the same voltage. If you observe here, this is the I0 waveform. So same waveform. If you take this as a source voltage, same this current will be continuous. So if you observe here, from alpha to pi the current will be continuous, no? So it is represented this with this orange color waveform. So the current will be continuous. Current will be continuous from alpha to pi. So the if you observe in the gate pulse from alpha to pi, thyristor T1 and D2 will be forward biased, and it will follows the source voltage, and the current will be continuous from alpha to pi. Next, from pi to pi plus alpha, pi to pi plus alpha. So if you observe from pi to pi plus alpha, there is no firing angle applied for any thyristor. So if you observe here, as there are conditions that to turn on the thyristor, it should have forward biased and the gate pulse should be applied. The gate pulse is not there now from pi to pi plus alpha. So T1 gets off. T1 gets off, or we will call it as T1 gets commutated. T1 gets commutated. So the thyristor T1 gets commutated, and the freewheeling diode action will continues. So the freewheeling diode will conduct here. So the freewheeling diode conduct here. So it is observed here. So the voltage will be short circuited now through freewheeling diode. So the voltage will be 0. So it is observed here, the voltage will be 0 at pi to pi plus alpha. But current will be continuous. So I0 current will be continuous. I0 current continuous. So it is represented like this. So from pi to pi plus alpha, current will be continuous, but the voltage will be 0 here. The voltage will be 0 from pi to pi plus alpha. Next we will observe for the alpha pi plus alpha to 2 pi. If you observe from pi plus alpha to 2 pi, so pi plus alpha to 2 pi. So from the pi plus alpha to 2 pi, if you observe here, the gate pulse is applied here. So the thyristor T2 gets turned on, as it is forward biased and the gate pulse is applied, T2 gets turned on, and the cycle from pi to 2 pi, D1 will be in conduction now. So D1 gets turned on. So the T2 and D1 will conduct from pi plus alpha to 2 pi. So here if you observe here, the T2 and D1 will conduct, and again from 2 pi to 2 pi plus alpha there is no firing pulse. So freewheeling diode action will continues. So the voltage will be 0 and the current will be continuous. Here also if you observe, the current will be continuous. The same cycle will be repeated for again 2 pi plus alpha to 3 pi and 3 pi to 3 pi plus alpha. The freewheeling diode will action will be continuous. So the same cycle will repeat. So if you observe only for current waveform, so if you observe current across thyristor T1, so the thyristor T1 will conduct from alpha to pi, no? So it is observed here from alpha to pi, the thyristor T1 will get conduction, and here the 2 pi plus alpha to 3 pi, again T1 will conduct. So I thyristor T1 will conduct from alpha to pi as well as 2 pi plus alpha to 3 pi. And the second waveform, if you see here, the freewheeling diode action. The freewheeling diode action will be takes place from 0 to alpha now. So here if you observe here, 0 to alpha, the freewheeling diode action will be takes place, and pi to pi plus alpha, same freewheeling diode action will takes place, and 2 pi to 2 pi plus alpha also freewheeling diode action takes place, and 3 pi to 3 pi plus alpha also freewheeling diode action will takes place. So the current across the freewheeling diode will flows through it. And the last waveform is the source current waveform. If you observe the source current waveform, the source current waveform will continues from only the thyristor current. So thyristor current from alpha to pi it will conduct, and pi to pi plus alpha the freewheeling diode action, no? So the current will be 0, and pi plus alpha to 2 pi it will conduct again. and 2 pi plus alpha, the freewheeling diode action will takes place, so it is 0, and 2 pi plus alpha to 3 pi, the current will continues. So these are the waveforms. If you observe from alpha to pi and pi to pi plus alpha and pi plus alpha to 2 pi, the same cycle will repeats. So if you take the torque and the speed characteristics and the voltage equations, if you see here, the voltage E alpha, EA at an angle alpha equal to EB plus IARE, EB plus IARE. So back EMF is also known as the Ka pi into omega, no? So I can substitute EA at an angle alpha equal to Ka pi plus IARE, Ka pi plus IARE. But we know that the voltage equation EA at an angle alpha, EA at an angle alpha can be taken as average voltage, average voltage. So this average voltage will be considered from the cycle. So average voltage, if you see from the cycle, the thyristor will conduct from alpha to pi, no? So we will represent the average voltage also from alpha to pi. So I can write the VA voltage as here. If I represent here the VA equal to the voltage VA, or I can also represent EA at an angle alpha is equal to 1 by pi. The cycle is from 1 by pi and it will conduct from alpha to pi, no? So alpha to pi, Vm sin omega t, Vm sin omega t and d omega t. So we will represent the boundary conditions. Vm is constant, so I am removing outside. Vm by pi sin omega t, integration of sin omega t, it will be cos omega t, and applying boundary conditions alpha and pi. So minus cos omega t EA at an angle alpha is equal to Vm by pi minus cos pi plus cos alpha. So it will be Vm by pi of minus of cos plus alpha, it will be minus of minus, it will be 1. So 1 plus cos alpha. So this is the value EA at an angle alpha equal to Vm by 1 plus cos alpha. So this is the current waveform. So I can substitute here EA at an angle alpha is equal to Em by pi 1 plus cos alpha. This I can substitute in the back EMF. So in the next class we will see the current and torque equations. Thank you guys.